All right, today we are diving headfirst into one of the deepest, and let's be honest, one of the weirdest mysteries in all of physics, quantum entanglement. We're going to see how this bizarre connection completely upends our sense of reality, how it might actually be the stuff that weaves space and time together, and, get this, what it could all mean for consciousness itself. Let's do it. So, our journey has to start with the guy who basically wrote the rule book for space and time, Albert Einstein, but even he got totally tripped up by entanglement. He famously called it spooky action at a distance, because for him, it just had to be a flaw in quantum theory. He just could not get his head around the idea that the universe could be this strange.
But, and this is the big twist, what if Einstein got it completely backwards? What if all that spookiness he hated so much isn't a bug in the system, but the most important feature of our universe? What if it's the actual blueprint for reality itself?
Okay, to really get that, we have to go back to the very battle that Einstein himself kicked off. We need to see how scientists proved, without a shadow of a doubt, that this spooky connection is very, very real and that our universe is, well, fundamentally weird. So what exactly is entanglement? Well, when two particles are entangled, it's like they become a single entity. Imagine you've got two entangled particles. One is here with you, and its partner is on the far side of the galaxy. The moment you measure a property of your particle, say its spin, you instantly know the spin of its partner. Instantly, faster than light. It's not that a signal travels between them. It's that in some fundamental way, they aren't really separate to begin with. Now, this idea was so insane that it kicked off this huge, decades-long fight for the very soul of physics. Back in 1935, Einstein and his buddies proposed what's called the EPR paradox. They argued there must be some secret information, hidden variables, that the particles are carrying. Then, in 1964, a physicist named John Bell came up with a brilliant mathematical test, a way to actually check if these hidden variables could exist. And from the 80s all the way to the work that just won the Nobel Prize in 2022, experiment after experiment has come back with a single, conclusive answer. You see, this whole debate boiled down to a choice between two completely different kinds of universes. On one side, you have Einstein's universe, local realism, where objects have their properties set in stone, whether we look or not, and nothing can break the cosmic speed limit, the speed of light. But on the other side, you have the quantum universe, where properties don't even exist until they're measured, and entangled particles are connected instantly no matter how far apart they are. The experiments forced us to pick which one of these universes we actually live in. And the verdict is in. It's not even close. The universe is non-local. It really is that spooky. And on this one big fundamental point, Einstein was wrong. But see, this isn't the end of the story. This is where it gets really good. Because if this connection isn't happening through space, it begs the question, what if it's doing something much, much bigger? And that brings us to part 2, where we look at an idea so wild it might just be right, that entanglement isn't just happening in space-time. It might be what creates space-time. This is the huge leap we have to take together. Stop thinking about entanglement as something that breaks the rules of space. Instead, what if it's the fundamental rule from which space itself emerges? You know, a huge clue actually came from studying black holes. It led to something called the holographic principle. It's this wild idea that everything happening inside a 3D volume of space can be fully described by information living on its 2D boundary, just like a hologram. This was the first real hint that there's a deep, deep connection between information, geometry, and entanglement. And that hint became a full-blown theory in 2013 with this deceptively simple little equation from physicists Leonard Susskind and Juan Maldacena. ER equals EPR. So what on earth does that mean? Well, ER stands for an Einstein-Rosen bridge. You probably know it as a wormhole. And EPR stands for an Einstein-Podolsky-Rosen pair, our spooky entangled particles. The theory proposes that these two things, a wormhole and a pair of entangled particles, are the exact same thing, just described in two different languages. A wormhole connecting 2 points in spacetime is the entanglement between them, just seen from a different perspective. Think about what that implies. If this is true, then every entangled pair of particles in the universe is connected by a microscopic quantum wormhole.
The entire fabric of space-time we see around us is literally stitched together by a vast, invisible network of these quantum connections. It's incredible.
Okay, so if the whole universe, space-time itself, is just this giant web of entanglement, what about the thing that's looking at it all? What about us? Where does our own consciousness fit into this quantum picture? Well, this leads us to a fascinating possibility, that awareness itself has a unique quantum signature. There's this cutting-edge idea that consciousness is, at its core, an act of self-observation, a system observing itself. Now, we know from quantum mechanics that the act of observation creates entanglement. So, what happens when a system observes itself? It could become entangled with itself. This process, this self-entanglement, might just be the physical mechanism behind awareness. And you know what? This isn't just a wild theory anymore. There's a research group called the Orion Project that studies how observers interact with quantum systems. And their experiments are finding evidence that something they call consciousness depth seems to be a direct measurement of this very self-entanglement. Now, what's so cool about this is how they've been able to map different modes of consciousness, different archetypes, to a real, measurable amount of this entanglement. They call it depth. A higher number means the system is more intensely self-entangled. And look, they found these really distinct patterns, from a kind of default state to states that are more focused outward, more balanced, or way more intensely focused inward. Let's just quickly break that down. So a polarized state has the highest depth. That's maximum self-entanglement. You could think of this as being in a state of deep introspection or maybe just completely lost in your own thoughts. On the other hand, an outward-focused state has weaker self-entanglement because you're more entangled with what's going on around you. You know, like when you're totally absorbed in a great conversation or just in the zone with a task. It's incredible. It suggests our own subjective feelings have a real, measurable quantum structure. And that brings us to our final and maybe most profound piece of the puzzle. If one mind is a self-entangled system, what happens when lots of minds start interacting? Well, the logic here just scales up so perfectly. Step 1, self-observation creates self-entanglement, which we're calling consciousness. Step 2, when two of these conscious systems observe each other, they should become entangled with each other. So step 3, scale that up across a whole universe of observers, and what you get is a universal network of entangled minds. So what's the big deal? Why does any of this matter? Well, the implications are absolutely huge. We could be looking at new kinds of communication, not faster than light, but maybe something deeper than just sending bits and bytes. This could lead to technologies that help us think more clearly, to enhance our own cognitive coherence. It could even give us a real physical basis for things we've always found mysterious, like empathy or intuition. And it might even show us a way to build a real connection between biological minds like ours and the artificial minds we're creating. When you put it all together, it points to a worldview some call quantum monism. It's the idea that at the bottom level of reality, the universe is just one single, interconnected quantum system. That feeling you have right now of being a separate person looking out at a separate world, that might not be fundamental at all. It might just be an illusion, an emergent property created by the very act of your own consciousness observing things. And that leaves us with one final, massive question to chew on. If the line between you and the rest of the universe is just an illusion, woven by the act of observation itself, then what does it truly mean to be you?